everybody, welcome to CS 201 week 4. So I went out with some co-workers after our curriculum committee meeting for my sort of other gig, and needless to say, it is late now. The module is supposed to be released in like 90 minutes at the time I'm recording this, so I've got to hurry. This is going to be one of those quick and dirty videos, super fast, no editing, but hopefully that won't be a problem because I tend to ramble when I don't edit, and that's not good, especially since this week we're talking about functions. Week 4 is going to be all about functions. Functions are sort of a building block of code in most programming languages. It sort of separates out just sort of a mash of like instructions bouncing from one instruction to another to really sort of packaging them together. And so that's the best way for me to think about what a function is. Kind of like a variable is a way of giving a name to a piece of data. A function is a way of giving a name to a set of instructions, right? So you can create a set of instructions and then just give it a name. If you've ever, taken one of those, like, been in school, like 3rd grade or whatever, right? You had your teacher at some point, maybe, I don't know, maybe this was just my school. She shows up with like a loaf of bread and a jar of peanut butter and like a butter knife and says, all right, give me the instructions to, make a peanut butter sandwich. And you say, oh, well, you put the peanut butter on the bread. And so she grabs the jar of peanut butter and places it on top of the loaf of bread. Okay, am I done? And you're like, oh, no, that's not how that works. You have to like open the bread and pull out 2 slices and then open the peanut butter and then take the knife and you have to go through all the different steps. And the idea is that we have these names that we use just in day-to-day living, right? Like, oh, I'm gonna make a peanut butter and jelly sandwich. Well, no, you're actually gonna do like 18 things, right? In the process of doing what we call making a peanut butter sandwich. You've given a name to a set of instructions. It's actually more complex. You just don't think about the sort of the details of that complexity. Well, computers, you always have to think about the details, so you can write these instructions and give them a name. A great way of thinking about this, it's going to be another cooking analogy, I apologize, but so old French cookbooks, right? French cooking is really unique because French cooking is very modular, right? So they have their mother sauces. You have your bechamel, your velouté, and these mother sauces get used to make more complex sauces. And then those other sauces are used in other recipes, right? And so the idea is that when you write a traditional French cookbook, you're going to skip a lot of steps because, like if I want to make a Mornay sauce, right? A Mornay sauce is a cheese sauce. I'm going to look at Mornay sauce, and the first thing it's going to say is make a bechamel. Well, what the heck is a bechamel? The idea is that they don't want to have to write those steps all over again, right? That's wasteful. What I'm going to do is go to the front of the book, because it's probably in the front of the book. Bechamel is one of the mother sauces. And there's going to be a recipe for making bechamel, right? What do? You add butter to a pan. You add, once it melts, you add flour to the pan. You sort of mix it together. You let it cook for just a minute to get rid of the cereal taste. Then you add milk, cold milk, slowly while whisking until you get this nice thick milk sauce. Although I think in the French tradition, you also use bay leaf. This is not a cooking class, right? But point being, that's a bechamel. What is it? It's a thick, white, milky sauce. If you're thinking to yourself, wait, if I just exchanged the butter for sausage, fat, I would end up with country gravy. Yeah, you're right. That's basically bechamel, but flavored with meat. Regardless, right? So then that set of steps, we can call that make bechamel. So when I'm going through the recipe for make Mornay sauce, right? I go make Mornay sauce, first step, make bechamel. Okay, so I'm going to leave this recipe. I'm going to go over to this other recipe, assuming I don't have it memorized, which if you're a French chef, you should have it memorized, right? I'm going to go through the steps to make bechamel. Then when I'm done with the steps for make bechamel, I will leave make bechamel because that is done. You can just pop that off the stack. Don't pay any attention to that phrase. It didn't happen. Don't worry about the underlying implementation. I'm going to leave that. We're done with it. I'm going to go back to my make Mornay sauce, and I'm going to finish the steps, which is just add a bunch of shredded Gruyere and Parmesan, and then whisk until melted. Done. You have a Mornay sauce. It's just a cheesy bechamel. But the idea here is that it's modular, right? I actually had a sort of a recipe called for in my Mornay sauce recipe. And of course, why are you making Mornay sauce? You're not going to just make Mornay sauce for the heck of it. You're probably making Mornay sauce because you actually were doing another recipe, and that recipe called for you to make Mornay sauce, right? Like if you just want to make mac and cheese, I mean, Jesus, boil pasta, make Mornay sauce. Oh, well, how do I make Mornay sauce? Leave that, go over to the make Mornay sauce recipe, start making the Mornay sauce. Oh, I gotta go make a bechamel, go over to the bechamel recipe, finish the bechamel recipe, go up, finish the Mornay sauce recipe. When you're finished with that, go back, finish the mac and cheese recipe, right? Mac and cheese. Somehow mac and cheese has made it into fine French cuisine. But regardless, you get the idea, right? It's modular. I'm giving names to a set of instructions. Make mac and cheese contains a call to the recipe for make Mornay sauce, which has a call to make bechamel. Sorry, got a tickle in my throat. And I'm not editing this. Right, so then that is a way of thinking about functions, but functions actually have a bit more to them. Because in addition to just being a name given to a set of instructions, a function can also take input and provide output, right? It can take arguments and actually return a value. The best way to think about this is actually in your math classes. I know, math. I apologize if you're a theater arts major. But like, if you're taking a math class, at some point in algebra, right, you got to that section, that chapter where they had like f of x, and like, okay, so the f of x equals 2x. And then I think you're supposed to, because this is kind of a weird way, like, so then you see a problem that says like the f of 3. So then you're supposed to take the 3 because you put the 3 in for the x, and so then you have to substitute it into the formula. So instead of 2x, it's actually now 2 times 3, which then, you multiply, gives you the value of 6. And so you would say, well, the f of 3 is 6. Well, all that substitution stuff is fine. That's math. But like, what are you really doing? When you set the f of x, you're defining a function. You're saying, what does it mean to f some? We're going to switch this to the g of x. The g of x is equal to 2x. What does it mean to g something, right? To g something is to, basically take it and then just double it, right? That's all you're doing. In fact, if they weren't mathematicians, they wouldn't have called the function g. They would have called it double, because that makes a whole lot of sense. Oh, I'm going to just double x. Well, what's that mean? I'm going to just multiply it by 2. Oh, so what's the double of 3? 6. I don't even need to know math to figure that out, right? But instead, you called it the g of x, and now it's all confusing. And I got to go look at this definition, which says that the g of x is 2x. So to g something is just to double it. And so the idea is that you could have, like, the g of 3. Well, the g of 3 is 6, because to g something is just to double it. If I have the g of 3, well, that's just going to be 12, because I take the 3, I double it to get 6, and then I double it again to get whatever. Like, you can have nested function calls and stuff. But the idea is I have this little thing. You might even hear an analogy of like a function machine. I have this little function machine that I called g, because I'm really bad at naming things. And then I said, well, if I take a 3 and I put it into my G machine's going to go poof, and in its place will be a 6, right? Because G's just double things. And then if I take that and I shove it into another G machine, well then poof, and you can kind of picture in code, that's going to switch into a 12. Now, obviously, that is not what happens in the machine at all. But if it helps as sort of like a high-level way of visualizing, you can picture it that way. Picture things going poof. Or I guess in math, you just cross them out. But I prefer stage magic, so poof, right? And then you get the result that comes back, that return value. That's something that functions have the ability to do in math. It's something that functions have the ability to do in computer science. The functions don't have to. You can have something that is more of a procedure or a subroutine, we might call it in computer science, where it is really just a name given to a set of instructions. But functions have more features, and so you can have that input-output relationship if you want. And just because it takes input doesn't mean it needs to provide output, and just because it provides output doesn't mean it needs to take input, although I guess you're going to get something from somewhere. It doesn't really matter. Point being, these are independent things, right? A function can return nothing if you wanted to. The details of how you write that in Python, you're going to see in the explorations with Chris Scafidi. So I won't necessarily talk about those. In fact, there'd be a better way of doing these videos to actually show you that, where I can actually see my screen. But as a high level concept, you can think of functions in those two ways. It's a name that we give to a set of instructions, and that set of instructions, that function, that now little packaged unit of code can be thought of as sort of a machine that can take in input and provide an output. Literally every time you make that function call, so you define a function generically. When you define the function generically, that's your f of x equals 2x. When you actually use it, right, when you make the function call, that's when you send it an argument. The f of 3 is 6, right? Functions, lots of it there, etc., etc. Your assignment for this week is going to be to write 3 functions that would be very useful for physicists. Everything from figuring out how far a star is, in the distance based on the speed at which it's, flying away from Earth. And if you don't know that all objects in space are flying away from Earth, actually they're all flying away from everything else in the universe. In addition, we just happen to be one of the things that they're flying away from. But expanding universe, that's a different class. But the function you're going to write, that sounds really complicated, but it actually turns out to be a stupid easy function. The math isn't going to be terribly difficult on all these. They're just going to be useful. And the assignment actually breaks down exactly what you need to do in terms of the function, like what the process is. Writing the function is going to be different. That's up to you in Python. Then we also have a discussion this week, so we go back to a discussion. The idea is that you guys are all non-computer science majors. So you've got majors that sort of span the gamut, right? I'm sure that you probably cluster in some groups just based on interest. But the idea here is go out and find a function that is useful to your discipline. It doesn't have to be useful to your discipline. It might not even be related to your discipline. It might just be a function that you found to be interesting. But what is that? Maybe it's something about epidemiology, although we kind of did that already with zombies. But it could be something else. It could be in psychology. I don't know. I don't have a degree in psychology. I don't know of any functions in psychology. How about business? I did have a bachelor's degree in economics, right? Maybe it's something to just calculate the amount you'd pay out on an annuity over time, or figure out the compound interest of something, or just mortgage rates. Figuring out how much you pay and how much you're going to pay over time for a mortgage rate. I think like every American should know that. And most have no clue. They just walk in and sign a pile of documents this big and have no idea what they're doing. But that's fine, right? The idea here is find a function that you think would be useful and share the function with the class. Now, you don't have to actually write it in Python. You're just sharing what the function is. If you want to, though, as extra practice, it's optional. It's not part of the grade. You're not going to be given, extra points. You're not going to be deducted points if you don't do this. But maybe try to actually write it in Python. It'd be great practice. The book mentions, hey, we also need a bunch of undergraduate TAs and the kind of people who do that sort of stuff, yada, yada. Point being, it's great practice. It's something that might be fun. So if you have a function that is useful in your discipline, or just a function that you like, maybe you've got a separate hobby and it's, boy, I'm really having a hard time thinking of examples, but you will hopefully do this. I immediately went to woodworking. I don't know woodworking. Is there a formula for how thick you need to make the legs of a dining room chair so that they can hold a certain amount of weight? I assume that must be the case, but I don't know that you would actually know that if you're a woodworker. Regardless, find a function, something you would find helpful. And then is there anything else we need to do? Nope, discussion, assignment, and learn about functions. And I have to figure out what this tickle on my throat is, and I need to quickly get these videos up onto YouTube and embedded before midnight, which is not that far away. So have a great night, and I will see you online.